The first thing to do here is to write out the chemical equation showing the decomposition of limestone to yield calcium oxide and carbon 4 oxide. So we have that to be CaCO3 to yield CaO plus CO2. Looking at this equation, we have a balanced chemical equation. And in the question, we have to determine the number of moles of limestone, that's CaCO3, that will be required to produce 5.6 grams of CaO. So to know the number of moles of CaCO3, from this equation, we can say 1 mole of CaCO3 will produce 1 moles of calcium oxide based on the equation above. So now what if we have 5.6 grams of calcium oxide? What moles of calcium triisocarbonate 4, that is limestone, will be required? We'll be making use of the formula that says moles equals to mass over molar mass. We've been given the mass of calcium oxide to be 5.6 grams, but we do not know the molar mass. So let's calculate molar mass of calcium oxide, and that will be equal to the sum of the atoms of the element present, which is calcium and oxygen. The atomic mass of calcium is 40 and oxygen is 16. So adding this up, we have 56, and the unit grams per mole. So substituting this into the formula we've written earlier, moles of calcium oxide will then be equal to 5.6 grams divided by 56 grams per mole. In calculating this, we have 0.1, the unit moles. So from here, we can just conclude that the number of moles of limestone that will be required will be 0.1 moles as well, according to the equation written above. But let's show the steps in getting that in situations wherein we do not have same values as their coefficient in the equation. So from here, to get the number of moles of limestone, we'll be making use of the relationship saying that 1 moles of limestone, that's CaCO3, will produce 1 moles of calcium oxide, CaO. The one is gotten from the coefficient in the equation above, that is the coefficient of the substance here. So X moles, we do not know the value of CaCO3 yet. Of CaCO3 produce 0.1 moles of CaO. So from here, making X the subject, X equals 1 moles multiplied by 0.1 moles divided by 1 moles, and this is equivalent to 0.1 moles, which should be serving as the final answer. We could have stopped here after getting the number of moles of calcium oxide, but we need to go through these steps in situation wherein we do not have the same value as coefficient of the substance involved in the question. So from here now, we've gotten the number of moles of calcium triisocarbonate 4, that is limestone, to be 0.1 moles, and that will be all. So with this, we've come to the end of the solution to the question. Do well to subscribe for more if you find this video helpful.